In this video, I'm going to create a confidence interval for proportion. My sample is a sample of people who have voted in this election. 24 out of 60 voters in this sample voted for Angela, who is the winner of the election. That's a p-hat of 24 divided by 60, or 40%. Here, I'm going to input a confidence level. Let's say I want to use a confidence level of 95%. Here, this is optional, but just in case I want to look at what my critical value z is, I can use a normal inverse, so norm.inv. And the input here is the left tail probability. So my left tail probability is going to be the left tail of the distribution plus the confidence level. So what I need to do here is click on that confidence level and add the left tail, which is actually half of the complement, or alpha over 2. So alpha is 1 minus the confidence level, and I divide that by 2. There's kind of easier ways to do that. If you create a separate cell for alpha, then you can always do 1 minus alpha over 2. But this works as well. It's a little more intuitive, I think. Okay, so the mean of this distribution is going to be 0 for a standard normal, and the standard deviation is 1. So there's my critical value. There are other ways to do this. I'm just using the norm inverse function for this. So that's about 1.96 standard deviations to get 95% of the z curve. Now the margin of error, there's two ways to do it. First way I'm going to do it is with a confidence function. So this is confidence.norm. And the inputs here are alpha first, so 1 minus confidence level. The next one is standard deviation. So I would put the standard error, except they're going to go ahead and divide by n. So really all I need here is square root of p times 1 minus p. In this case, p hat times 1 minus p hat. And that's a little confusing. Usually you divide by n, but I'm just letting you know they're going to divide by that n within the square root automatically. And then lastly, population size. I can use a cell reference there as well. Or you can type in these numbers as you go. So that's about a 12% margin of error. We should see the same thing if we go to Staplet. We're going to look at a categorical variable. And I'll just do that real quick here. So here we see we get our margin of error is 40%. Plus 12.4% to get 52.4, or 40% minus 12.4% to get 27.6. That's the same 12.4% we see here. If you want to change it to a percent, you can, or you can go back to format, number, automatic, and change it back to a decimal. For the upper and lower bound, what we're going to want to do is use the p-hat. Start with an equal sign. P-hat minus the margin of error, and p-hat plus the margin of error. And looks like I messed that up. So equals p-hat plus the margin of error. If you want more accuracy on that, you can shift your decimals over that way. There is an alternate way to find E. Just going into the population proportion formulas, E is z alpha over 2 times square root of p-hat times 1 minus p-hat over n. So next to E, I'm going to do it that way. I'm going to do my critical value times square root. And then in the parentheses, p-hat times 1 minus p-hat. And still in the parentheses, divided by n. And then close that parenthesis for the square root. I should get that same amount there.